Hello everyone. I hope all of you are doing well. I'm Aman, your physics teacher, and today we are going to discuss the most interesting and most fascinating topic of the modern physics, the photoelectric effect. So, from the exam perspective, it covers one question every year in JEE Mains, and for the JEE Advance, it covers 3 to 8 marks. It is roughly one or two questions, but it is not frequent as in the mains it has one question almost every year. So now we are going to discuss that how photoelectric effect works and what are the experimental conditions and what are the uh, theories are given by Einstein and how light behaves differently. So before we start, I have one question. Suppose that we have two lights. One is red bright light and another is violet dim light. What do you think? Which light has more energy? Which light is more energetic? This red bright light or this violet dim light? So some of you are saying this red light has more energy, this bright light has more energy, and some of you are saying that this violet dim light has more energy. Most of people, you are thinking that the bright light has more energy because it is bright. So today we are going to discuss that how nature behaves differently, especially in this situation. So we are starting with our experimental part, that how photoelectric effect occurs and how photoelectron are coming out from the metal surface. So first of all, we have one metal plate which consists of many electrons, and especially the surface electrons. We are discussing the surface electrons because it has lower binding energy. So this is the metal. All of we know that electrons are bounded to the central atoms and positive atoms in the metal surface. So if electrons want to go out from the metal surface, it has something, it has some energy, some minimum amount of energy requires to free the electron from the metal surface. This electrons are called as photoelectron, which is which electrons are getting energy, getting required energy and go out from the metal surface is called as photoelectrons. So this is the photoelectric effect, the phenomena. So we are frequency, threshold wavelength, cutoff frequency, and work function as well. But let's get back to the question. What do you think that what happens when we make our light brighter, more brighter? Most of you think, and also classical theory predicts that when the intensity is high, intensity means brightness is high. This bright light, this is bright and this is dim. It means that red light has more intensity and violet light has uh, lower intensity. So when we have high intensity, so also we have a high energy, and high energy means that we have a more number of free electrons from the metal surface because we have high energy. So we give this energy to the metal plate and surface electrons are going up and free from the metal. So classical theory predicts the same thing, but experiment I completely disagreed from this classical prediction. We can see how it works. So before understand that how it is happens, we have to understand what is the Einstein's theory of light. In the 1905, Einstein told us that light is not a wave. It behaves also like a particle, and it consists of tiny packets, energy of packets, which is called as photons, which is called as photons. And the energy of the photon, one energy is equivalent to this, E is equal to h nu, where E is the energy of photon, h is the Planck's constant, nu is the frequency. So all of these things, this bright light, this dim light, red and violet light, what happens in the experiment? Violet light, which is dim, are emitting more number of electrons than this red bright light. This red bright light has no free electrons, no photoelectrons, because the red light has lower frequency, but this violet light has higher frequency, and the energy and number of photoelectrons are totally depend on the frequency. Which light has higher frequency, that light has higher energy. So now coming back to the our photoelectric effect experimental part, we have one useful formula. We can write this: E is equal to h nu. Okay, so so now we are discussing that how frequency matters for the photoelectrons phenomena, that how electrons freeze from the surface, and how frequency and wavelength take place into the theory and the experimental part. So let's take an example of staircase. One building has staircase only to go to the next floors or the below floors. So it is like this structure. So suppose that you are here in the first floor. If you want to go in the next floors, you have to climb something, you have to climb some height of staircase. Like this height you will cover, this height you have to cover. To reach this floor, you have to cover this much of height. Same things happen with the photoelectrons, same thing happen with the electrons. When our electrons are getting minimum amount of energy, it will be free from the metal surface. Like take another example of zoo. Suppose that you are going to the visit of the zoo and the entry is free. You visited, you see all the animals and you enjoyed a lot. When you are coming out, the condition is that you have to pay 100 rupees for exit. If you want to go outside the zoo, you have to pay 100 rupees. So this is the condition. Suppose that you don't have money, you don't have 100 rupees in your pocket or on your phone. So what happens if you have 90 rupees, 70 rupees, 40 rupees, whatever is less than 100? If you have less than 100 rupees, you are not allowed to go outside from the zoo. But let's suppose one person has 100 rupees, one person has 120 rupees, one person has 1.5 lakh rupees. What happens to this person? They are allowed to go outside from the zoo. They will give 100 rupees to the person and go outside from the zoo. Same thing happens to the electrons. When electrons want to go outside from the metal surface, it has to pay some amount of energy to the metal, which is called as work function. The minimum amount of energy which is required to free the electron from the surface, and which is called as photoelectrons. So this is a work function. The frequency we need to free the electron from the surface is called as threshold frequency. So this is for the experimental part, that how electrons are free from the metal surface, what is work function, and what is threshold frequency. Now we are discussing that what is the formula for this experiment. Let's suppose here we are. This is light coming into the surface. It has some energy, like work function. So metal electrons are free from the metal surface, and the remaining energy take place into the rotational or motion energy for this electron, which is kinetic energy, and it has maximum part of it. So okay, so now we have this metal, light coming up. The energy of light is h nu. The photon, electrons are going out. There are free electrons, photoelectrons. So h nu is the incoming energy. When these electrons are free from the surface, when it gets the minimum amount of energy, this is work function, and the remaining energy is called as maximum kinetic energy for the electron. It moves with this much amount of kinetic energy. So this is the so now we have these two formulas. When we put the value of work functions shows the value of h nu naught, where nu naught is equal to threshold frequency. The minimum amount of frequency required to free the electron from the metal surface. So h nu is equal to h nu naught plus k max. So now we are trying to plot the graph between k max and nu. So k max has value is equal to h nu minus h nu naught. Here we can compare this equation by y is equal to mx plus c. So from y, the kmax is on y-axis. In x-axis, we have a frequency. The slope is m, and intersect is this. This is frequency. This is maximum kinetic energy of the electron. This is intercept. It means it passing from it. This is h nu naught. Obviously, this is minus. The slope of the graph is h. This is the slope of the graph. So this is the third equation. All of we are know that c is equal to nu into lambda, where c is the speed of light, nu is frequency of light, and l is the wavelength of the light. Now make the equation for nu. It gives c by lambda. So putting this into this, c by lambda, h c by lambda naught. This is threshold wavelength plus k max. Equation 4. When we are trying to plot the graph for this equation, we have a k max on y axis, c 1 by lambda on x axis. The slope is hc. This is our intercept c. So this we have on this formula, the plot. Now we are able to see that when we have a zero threshold frequency, this as zero threshold frequency, we doesn't have the value of kinetic energy. Kinetic energy is zero. When we are increasing our threshold frequency, kinetic energy are also increasing in the positive direction, and it moves linearly. So it shows that when we are increasing the threshold frequency, when we apply higher amount of energy on the electron, it has excessive energy, and is in the terms of kinetic energy. So the condition for the photoelectric effect is that our electron energy, photon energy, is equal or higher than 5 knot work function. This is the condition for the photoelectric effects. Okay, so from the formula and from the theoretical part, now we are discussing one question for the photoelectric effect. The question is as we have an ultraviolet light wavelength is given as 280 nanometer used in a experiment of photoelectric effect with lithium cathode. We are given with lithium cathode and the work function for this is given as 2.5 electron volt. So what is the maximum kinetic energy of the photoelectrons? We are asking, question is asking that what is the maximum kinetic energy for this experiment. So we have a formula which includes wavelength, work function, this equation 4. So Kmax equals to hc by lambda, and this is our work function. So we are putting the values of all these things. Before putting the values, I have one short trick to you, that when we are given with h and c and the lambda in the terms of nanometer, we can write this as 1242 by electron volt nanometer by nanometer. This is the wavelength in the units of nanometer. This is the multiplication of h and c. You don't have to multiply h and c. We are given that 1242 electron volt nanometer. This is the unit. So when we are putting the value of wavelength, this will cancel and we have the final value of this term as in unit of electron volt. So we are putting this 1242. We have a 280 electron volt nanometer, and this is in nanometer. Work function has its value of 2.5 electron volt. So now we are calculating that nanometer cancels. So this we have. So now dividing both these terms, we get, like suppose that this is 300. First we have 4 when we divide this by this. So reminder is 20 into 4, 80. So 1200 minus 80, like 1120. We have the value 80 plus 42, 112. This is our value. Now we doesn't have any point here, so we can take 0 and give a point to this, and this is 4. So 4.4 electron volt, this gives 4.4 electron volt, and this is 2.5 electron volt. So we have here 3, 1.4 plus 0.5, 1.9 electron volt as the maximum kinetic energy for this photo electron. So this is the example. So this is the photoelectric effect experimental part, how photoelectric effect occurs, what are the conditions, what are the requirements, how we are getting the formulas, what is threshold frequency, what is threshold wavelength, and what are the work function. So concluding that every theory has the real world applications for it. So for the photoelectric effect, we have a very useful kind of applications like solar cell, automatic doors, and sensors. All of these things are based on the principle of photoelectric effects. So thank you for today. In the next class, we are discussing more numerical questions.